8:30, right click, edit with notepad. So we build neural network with CPU, with the GPU, isn't it? And we build with TensorFlow and all those things. So if, what is today's date, 20th? If TensorFlow is backend, then Keras is front end. Keras is front end. One moment. One second. Front end. All right. We done this. So today, and also we started working on PySpark and how to read the data frame in the PySpark. We understood yesterday, isn't it? And rename, how to add the columns, all those things, if time allows, today we understand. All right. If not, then today I very important sessions which I gonna start is called CNN. Okay. CNN means convolutions neural network. Convolutions neural network. So understand the architectures of ANN. So we saw input layers, we have hidden layers, and we have output layers. Agree or not? And activation functions we implement in input, hidden, and can't hear you. Guys, can you hear me? One moment. One second. Yeah. Can you hear me, guys? Online team. Yes. Akshay, check your connections because everybody hear me. Okay. Yeah. So we do see all the activation functions. We do discuss all the activations functions, isn't it? And now let's understand. Today's session is quite important, and I will tell you in detail about all these things, and let's understand, guys. So in previous days, we discussed what is deep learning framework, installations, neural network architectures, what is neuron, what is signal, what is forward propagation, what is back propagation, what is epoch, what is activation functions. We done some of the practical called customer churn predictions using TensorFlow and Keras, isn't it, guys? These things we already done. And right now, and deep learning, these are the frameworks, and I'll deep learning method of AI, and this is the main important part we have. And so what is meant by framework? Framework can refer to a structure. It could be structured of a system, a building, or a project, isn't it? Frameworks are a huge help to developers in designing products. Agree? And they provides an infrastructures that has already figured out low level details, allowing the developer to focus on the unique detail of specific projects. Understand, guys? And the next one, so we have this part, installations of TensorFlow, Keras, PyTorch. We had exciting classes on those days, and so that you guys installed in your machines. Now, what is neural network architectures? We saw what is input layers, what is hidden layer, and what is output layer. The architectures of neural network is made up of an input, output, and hidden layers. Neural network themselves, or artificial neural networks, it is a subset of machine learning designed to mimic the processing power of human brain. We discuss the mosquito examples or not. Now the next step is, we done this activation function sigmoid, and then feed forward, back propagations, all those things we done. And the next step, we have rectifiers, ReLU, softmax. So except softmax, rest of them we used in, where we use, guys? Binary class classification. So only softmax we used. So this is forward propagations, this is back propagations, the weights are adjust. So this is what we done. And okay, now Today we start convolutions neural network. Are you guys understand? So each and every detail I will cover up in this classes, guys, and let's understand all those things. So here, introductions to CNN. But before that, just one moment. Convolutions neural network. Before understanding CNN, let's understand about two core subjects, image processing and computer vision. Image processing is a method to perform some operations on image. So these image processing does not done by sklearn, does not done by sklearn. So in order to get an enhanced image to extract some useful information from it, okay, and for image processing, we have a subfield called computer vision, isn't it? So computer vision is a field of computer science that works on enabling computers to see, identify, and process images in the same way the human vision does. I guess understand? Means, and then provide appropriate output. So anyway, this is just a difference, and I just talk about these two things. And do you see, if you see this image, it looks like mirror image, isn't it? And the computer vision, because the moment when I see this image from my eyes, it understand this is two faces looking at each other, isn't it? And also, if you see the white pot, it looks like a white pot, isn't it? Look at the only white objects, all right? And then one is artificial bird, but one is natural bird, isn't it? So a human brain easily recognize which is artificial and which is natural birds, guys. Understand? And if you see this one, guys, from last 5 years, from the past 5 years, this is CNN graph is blue and ANN is red. So if you compare both the graphs, so what happened? Which graph is more, incline? Growth is high, CNN or RNN, guys? CNN, look at this 2013 to 15, the growths are exponential increase compared to ANN. So CNN is very powerful, and the minimum package of CNN developer starts from, you can assume more than 20, something like that, guys. Okay, so this is all those things. But here, so the two things, how exactly CNN does. So I always tells you the first thing, 2D means black and white, isn't it? Two dimensions means black and white. Three dimensions means red, green, blue, RGB. Okay. So God given us rainbow color, isn't it? How many colors, guys? Rainbow, 7 colors. So all the colors are made up with a mixture of 7 colors or not, guys? Isn't it? So the same way in computer vision, we have it's 7D given by God, and now we have 3D for computer vision, guys, isn't it? Three dimensions means RGB, red, green, blue. Understand, team, up to this? And the next one, let's go to this one. So, okay, but before we continue this session, there's a fourth step you must need to understand. And once you understand, then the step one is convolution. The step one is convolution. And the step two is max pooling. The step two is max pooling. And step three, first we understand concepts, math, and then we go ahead for model building. And then flattening. And then step four is fully connected layer. Fully connected layer. Guys, understand how many steps we have? 4 steps. So we'll understand one by one. So what exactly happened? So let's assume, guys, 2 dimension is black and white. 3 dimensions means what? Red, green, blue, RGB. This is black and white image. This is colored image. This is colored image. Are you guys understand or not? Okay. So before I go ahead, before I talk about convolutions, I wanted to, so for OpenCV, there are two packages. I mean, computer vision, So there's a two packages like OpenCV and yellow. Right now, yellow version starts from V3, V4, V5, V6, V7, V8. Actually, yellow mostly it runs on GPU only, not CPU. As computer vision is OpenCV is user friendly with any platforms, so we can focus on OpenCV, guys. Are you understand? So the first thing, I hope everybody install OpenCV under TensorFlow and base, isn't it? Both. So the moment when you installed OpenCV package, okay, to your machines. Now let's understand. I will what is meant by convolutions. We'll understand step by step and I'll explain very slowly. So what exactly happened, guys? If you see this is one image, right? What is a real image, guys? Is it 8? What is real image? 8 digit. Represents in the form of an array. While you represent in the form of an array, so this would be colored image will be get back to like this with you get the grids or not. This is called pixels. And once you digit 8 represents in the form of pixels of zeros and ones. I mean to say, if you trained any image, to the system, this image will convert to the pixels. So each leaf image will be broken down into pixel depending on the dimensions of the image. For example, the image is completed by 30 into 30 pixels, then total number of pixels will be 900. Your camera is megapixels or not? We buy the camera 25 megapixel, all those things. What do you mean by that? That means when you install OpenCV, all images will be break down into pixel. So who does this? This is all done by inbuilt functionality of OpenCV. Team, am I clear online, guys? Who done this, guys? Inbuilt functionalities by FNCTIO LITY functionality by OpenCV. Are you guys clear? But before I go ahead, I will start one of the very important topic. First, before I go to human vision, first I will talk computer vision, human vision versus computer vision, isn't it? So what is meant by human vision? When a small kid, when a kid is birth, he don't know the world, isn't it? The parents, the grandparents, they teach to them stating, okay, this is cat. If how they train to the kid's brain, the cat is the first they will train with the edges. What are the edges? Do you think the train with cat ear is pointed, isn't it? And the cat eye is cat eyes, isn't it? And then height of the cat is less, and then leg is 4. These are the edges or not, guys? Edge feature of the image. So the moment when you train these attributes to the kid's brain, now kid starts understanding. One time only train, then till the time in the entire life he can recognize it is a cat, isn't it or not, guys? You guys understand? The same way this is human vision does. The reason being, the human vision means what exactly happened. So in human, we have brain cerebral cortex because in human brain, it consists of multiple layers, guys. Layer 1, layer 2, layer 3, layer 4. So what exactly it does? First layer, it understand cat ears, isn't it? In layer 2, it understand height of the image. In layer 3, it understand the four legs. And layer 4, it understand cat eyes. Did you understand? Each and every layer can understand some of the informations of an attributes, and finally it's stored in the human brain, isn't it? This is called human vision. Are you guys understand or not? The same way, how exactly, so all these things we have. So as I said, human brain contains multiple layers. V1, layer 1, layer 2, layer 3, layer 4, and finally the the image is stored in the human's brain, guys, isn't it? This is human vision. But before that, what is computer vision? So before I go ahead, let's try to understand max pooling, sorry, convolutions. In the convolutions, so understand this, guys. Before I go back to this, I will explain this. Let's say I trained an image. I have one image, guys. This image will convert to pixels or not, guys? Remember, each and every pixel's range is 0 to 255. What exactly the pixels range, guys? 0 to 255. So here, 1 second. Okay, two dimensions array. Every pixels, this is black and white image with 2 into 2 pixels. This is colored images. And the pixel one, what is the range of the pixels, guys? 0 to 255. 0 to 255 every pixels, guys. And see, if it's a happy faces, isn't it? The face is happy, the happy emoji. So this is what happened, and it will convert to zeros and ones like this, zeros and ones like this. Understand? So there are three things we understand. And before that, let's minimize and okay, let's start. So what happened? As I said, every image will split into the pixels. What is the range of the pixels, guys? 0 to 255. Okay. So assume, yes. So let's go to, I have one image. Okay. Let's say this, don't ask her which image you draw. This is just an image, for example. Getting me? So once you install this image will convert to the pixels, guys. So what is the dimension of the pixels, guys? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Can I say 6 into 6 matrix or not? In ANN, we call as input layer. In CNN, we call as input matrix. Clear? Clear or not? Into filter. What is filter? Means hidden layer, isn't it? Let's assume like that. So filter, how many filters? 3 into 3 matrix is filter, is equals to, what is output? 1, 2, 3, 4. 4 into 4 matrix. Are you guys clear or not? Input layer, hidden layer, output layer. The same way, input matrix, filter, and input matrix, filter, and output matrix, guys. But how exactly the -4 is creates? How exactly the -4 creates? Let's understand. I wanted to give you one example here, and I want to understand in detail, guys. So let's close this and okay. So convolution is a, what is convolutions layer? Let's come. Okay. So convolution is a mathematical operation that allows the merging of two set of informations. In this case of CNN, convolution is applied to the input data to filter informations and produce a feature map. And the filter is also called as a kernel and feature detector. I'll come back everything, guys. Before that, let's understand here multiplications operations. I will come back to that. So here, but before that, how to let's matrix multiply this one. So how many filters this one? 3 into 3. Let's apply this filter on top of this matrix. I guess understand or not? Let's apply top of this. When we do multiplications, 0 into 1, 0 plus 0 into 0, can we get the 0 or not, guys? You understand how to do this? I hope you know the matrix multiplications, as you said. Okay. Once we do this, once we compute, by default, we move to one step right. This is called striding. What concepts, guys? This is called striding. What I'll tell you. This is called striding. Just one moment. Okay, this is one step right. When we compute, we got the value as -4. And after that, what is the next step? Can we do one stride right? One stride right. We get this output. And what is finally? Another one stride right. We doing the striding horizontal or vertical, guys? Horizontal we doing? Online team, you understand? Because how exactly this input matrix generates, guys? Because if you train an image, the image will split into the pixel. Once the image is trained into the pixels, we apply filter to the pixels. Once we apply to the filter to the pixels, what happened? We do every stride part. Maybe once we done, what is the next step? One stride down, isn't it? And then what is next step? One stride down now. And finally, can we create this, guys? You understand? So what happened when you do this? Can we apply this formula right now? The formula is, just follow this. Look at this, guys. Now, so this one, if you one stride right, what happened? 0 into 0 plus 1, 0 plus 0 into 0, 1 into -1, -1. Am I clear? Now 0, 0, 1 into -2, -2. 1 into -1, -1, -1, -2, -3, -1, -4. So we filled with the -4. Online team, are you getting me or not? Means, how do you do matrix multiplications? So are you guys understand what is meant by striding or not? What is meant by striding? Everybody's clear? The striding concepts, it comes with convolutions. But here, if you notice one thing, guys, the input is very simple. What I'm trying to do, I'll open one more time. Look at this. So convolutions, if I train an image, the image will split into the pixels. Okay. And we apply a filter to that and we get an output. Very simple. What I'm going to do. So assume I have one input image, input matrix. This is filters. Now let's apply the filter matrix on top of input. Can we do the formula? 4 into 1, 1, 9 into 0, 2 into -1, -2, plus 5 into 1, plus 6 into 0, 2 into -1, -2, 2 into 1, plus 4 into 0, plus 5 into -1. Will you solve this? When you solve this, will we get the output? Yes or no? Again, I'm saying how we decide the dimensions of filters. There's a 2 dimensions. By default, it is 3D. Remember that. Okay, Yamini? Okay, so Ranjit, by default, it is 3D, 3 dimensions. Maximum, we apply 3 dimensions over here. Clear, Yamini? Okay. Now we understood the convolutions, we understood the filters. See, will you do this? Once we compute next step, what is the next step? One stride right. Can we apply the same thing or not? So how to apply? 9 into 1 plus 2 into 0 plus 5 into -1. 6 into 1 plus 2 into 0, 4 into -1. 4 into 1, 5 into 0, 4 into -1. Can we create another resultant vector, which is, I'll come back, man. Once we done this, what exactly happened? The 6 is generates or not? Clear up to this? So clear up to this. In striding, what is striding by default? How to get this value? Clear everybody up to this, guys? How to get another value? Let's try another stride. 2 into 1 plus 5 into 0 plus 8 into -1. We get some values or not? Team, you understand what I'm saying? Okay. But here the main problem is input is 6 into 6 matrix, filter is 3 into 3, but output is 4 into 4. Okay. So input image and output image, is it equal? No. So input image is greater than output image. That means we lose some clarity here. That means we lose some features. We lose some clarity here. Guys, are you getting my point? Because the input matrix is not equal to, the input matrix is not equal to output matrix. So that's why we are use the concepts called padding. That's why we use the concepts called padding. So what exactly padding does? So just we're going to do this now. We're going to do this now. Just padding in CNN. Just one moment. What we done, guys? Have a look at it. So this is what we have here. 6 into 6 input matrix and 3 into 3 output. We lose some data or not? We lose some data. The clarity is miss. So what you do? What is when we're pairing? So you need to add one layer, one matrix to avoiding one pad to each and every side of the matrix. Let's do this. And 1, 2, and then 3, 4, and then we try this now. But before I do this, one moment. But before I do this, I want to create one formula. Can we create one formula equal to n is equal to 6, isn't it? Input matrix is filter equal to 3. So I think n minus f plus 1. So 6 minus 3 plus 1 is equal to 4 into 4 or not? N minus f plus 1. So the formula I can create here is n minus f plus 1. So what is n, guys? Input matrix minus filter plus 1. Before I go to striding, so pairing, we can find out one formula here. Look at this, guys. Parameters. So are you guys understand or not? Online team, offline team. Team, did you clear or not clear? Online guys, can you respond me, please? Everybody? Yes or not? Tilt. Whatever I covered, I hope it's crystal clear. What is convolutions? How the image is split? How to implement the pixels? And how the filters are assigned? How the hidden layers are assigned, guys? Who assigned the hidden layers? User or not? Isn't it the same with filters? Will be assigned by users, and by default it is 3 dimensions. By default it is 3 dimensions. So the problem is here the input matrix is 6 into 6, but the filter is 3 into 3 and output is 4 into 4. So input is not equal to output. We lose some data. So that's why I'll use one padding each and every side of the data. So let's go ahead and do this. 1, 2, 3, 4, 5, and this. Continue this one. 1, 2. Clear or not? But what is the matrix now? 1, 2, 3, 4, 5, 6, 7, 8. No, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 into 8 or not? And this would be, what is the output now? N minus f plus 1. N is 8 minus 3 plus 1. Now input equal to output or not? Guys, are you getting my point? So, but what is pattern by default is how many steps we done? P equal to 1. P is equal to, can we say this or not? P equals to 1. But how to impute with these missing values? How to impute with these values, guys? Either you can impute with 0 or nearest neighbors. 0 or nearest neighbor. What is the nearest neighbor? 0, 0. What is nearest neighbor? 1, 1, 1, 1, and 1, 1, 1, 1, 1, 1, 1 as well. And then 0, 0, 0, 0, 0, 0, 0. Or by default, it would be 0 also. Clear or not? Now, can we do the, if you apply same filter concepts here, we get these values, guys. We get these values. Team, are you understand or not? So what is meant by padding? So here, let's, so look at this striding. Let's, stride denotes how many steps we are moving in each steps in convolutions. By default, it is 1. We can observe that the size of the output is smaller than input, isn't it? Because 6 into 6 input matrix is greater than output matrix. So that's why what we do, the next step is padding. So in padding, what happens? Stride denotes how many steps we are moving in each steps in convolutions. By default, it is 1. We can observe that the size of output is smaller than input. To maintain the dimensions of output as input, we use padding. So what is a padding? Padding is a process of adding zeros to the input matrix symmetrically. So guys, did you understand? 6 into 6 image. Now if you add p equals to 1, what happened? With 1 layer of 0 padding. So guys, are you getting me? So when you apply this, what happened? It creates extra space within an element. In contrast, margin create around the element. So team, I hope understand all these things, guys. Are you guys clear? Or online team, everybody? Online team, everybody, I hope you're clear. So what exactly it does, it make to the dimensions equal, like input matrix equals to output matrix, is called convolutions. In convolutions neural network, the first topic, which is convolution, is clear. Anybody have any questions so far? If no, then I will go to the next one. But before that, I will try to show you some of the convolutions layer. Also, convolutions layer is the first layer of convolutions neural network, while convolutions layers can be followed by or pooling layers, the fully connected layer. So no need to worry. I will a little bit go to images, then things would be more clear. And here, I will tell you what is meant by feature map. Okay. Wait. Are you getting my point or not? So this is theory we're discussing. Okay. And practicals, I will tell you. So first we understand each and every steps, then we get back to the another one part. So here I will mention few details. Look at this. So what we understand, guys, I will repeat again. Convolutions layer, we have input image. Okay, look at this, guys. This is feature detector. This is feature map. Remember two things, guys. This is what we call right now input matrix, input image, isn't it? If you train an image, that image will transfer to pixels, isn't it? Matrix. This matrix called input image into feature detector, which is called filters, which is called feature map. This is output matrix. This is called output matrix. So here, what we have in, I'll mention each and everything in the notes. So the first thing is input matrix, or we call as input image. The formula, convolutions formula. Remember this, guys. Convolutions formula. Input matrix or input image. Am I clear or not? We input matrix also we call as input image. Now filter also call as feature detector. Feature detector. It detect the features, guys. Are you understand him? It detect the features. Output matrix, also called as feature map, also called as feature map. So most of the interviews, they will ask input image feature detectors and okay, so all those things you can. So first you understand, then if you understand, then practicals are easy. If you understand, then practicals are easy. Team, am I clear? So input image into feature detectors is feature map. So we understand the few things like what is input matrix, what is filter, what is output matrix. We understood, and this is all about convolutions layer. This is all about convolutions layer. So this is the first process of CNN algorithms, guys, or CNN convolutions neural network. This is the first process of CNN part. Am I clear or not? Okay, just right click and open image new tab. I try to make things so this is what traffic signal. If you have these features will be convert into this traffic, guys. So I will show you all those things in practically rather than go for theory. If everybody's understand, then I'll go to the next concepts, which is called max pooling, which is called max pooling. So before I max pooling, so convolutions layer, I mentioned all the documents, and before that striding and padding. So I will get back to this one as well. Stride and padding in CNN. Okay, look at this. Look at this, guys. It's very straightforward. If you see this image, we have kernel, we have apply input, we generate output, isn't it? Yes or not? How many steps? One step stride or not? This is always one step stride. So stride denotes how many steps we are moving in each step in convolutions. By default, it is one. By default, it is one. And this striding we can implement in convolutions layer. We can observe that the size of output is smaller than input, isn't it? The size of output is smaller than size of input. To maintain dimensions of output as an input, we use padding, isn't it? To use the dimensions of input equals to output, then we use padding. And then it is a process by adding 0 to input symmetrical matrices, guys, to symmetrical matrices. Clear? So, so these things we understand. Let's go to max pooling. What is the next step, guys? We'll go ahead to max pooling. Shall we continue? Shall we continue? Online team. Yes. So very simple. So how we done this? We have some image. We convert into the pixels. Okay. And then we apply a filter and we generate some output metrics. Am I clear? This is called convolutions layers. This is called convolutions layer. Clear up to this? Now, next step, max pooling. Remember, max pooling always apply here, output layer, not here. Are you guys understand or not? Max pooling always implement apply at output layer. So if you go back to this, max pooling always apply at output layer. So what happened here? I'll go ahead and let's look at this. Before I go back to the work, max pooling. So assume we have input matrix. We have like what, guys? This is filter and this is output matrix. So here max pooling we apply at output layer. But my question is, how many dimensions? 2D. So in 2D, what is the maximum value? Max pool, isn't it? 1, 2, 4, 3. What is maximum data, guys? So we pulled 4. 2, 3, 3, 6. How many maximum value? We pulled 6. And what about 4, 3, 2, 8? 8. What is the maximum value we pulled? So now from the output metrics, when you pulled maximum values, we get clarity or not? When you download the Blu-ray movies, it's 4 GB movies or not? 4 GB means why it takes more data, because the max pull that, I mean, it won't take the minimum values, the maximum pixels data only it captured. So that's why you get the camera cost is very high, guys, isn't it? So team, are you understand or not what exactly I'm saying? So I mean to say, just go back and have a look at this. This works by selecting the maximum value from every pool. Max pooling retains the most prominent features of the feature map. Feature map. What is feature map? What is feature map? Field output. And no, in output, feature map is output. Feature detector is filter. Feature detector is, and the returned image is sharper than original image. Max pooling is a pooling operations that calculates the maximum value of a feature map, isn't it? The maximum value of a, and it uses creates a downsampled pooled feature map. For example, we have 22. So look at this, guys. This is what 2294 max pooling. 9 we pulled or not? Filter 2, stride 2 into 2, and then 2 stride. This is 1 stride, 1 step or not? This is 2 stride. 7361, the maximum is 7, and 8531, 8. 2426, the maximum is 6. Did you understand or not? It is usually used after convolutions layer. It usually used when, guys? After convolutions layer. So what is convolutions layer? Are we understand or not? So this is convolutions layer. We have one image. I guys understand? From